Hello everybody. This is the final video in this R studio series where we're learning how to do descriptive statistics. So this video, we're actually going to learn how to do descriptive statistics by creating a data frame in R. So we've already done analysis with a built-in data set. Then we actually imported a data set. Now we're actually going to type in a particular data set and then generate a couple of charts on that particular data set. So I have my R script all ready. I've already set my working directory and cleaned my environment just to make life easy for me. So let's go ahead and create this particular data frame. So what I actually want to do is I want to put in data on the US commercial space revenues from 1990 to 1994. So these are all revenues that different US industries earn, industries that are involved in space research that they earned in 1990, 91, 92, 93, and 94. So in all of those 5 years. And I have information in thousands of dollars. The unit is thousands of dollars. So, and I have about 5 industries and 5 years of data. So I have 5 industries, 5 years of data. So I have 25 revenue values in total. So let me very briefly show you what the data actually looks like and how I want to put it into R. So I'm not sure if you can see. Yes, so this is the table that I want to input and create in R. I want you to notice 2 things. Notice the number in the rows. So the numbers, so for the first industry, the commercial satellites delivered industry, the revenues were 1,000 in 90, in 1,300 in 91, and then it went down to 1,100 millions. Sorry, this is actually in thousands of dollars. The millions there is a typo. 1,100, then 1,400. So that's all for commercial satellites industry. Then for satellite services, we have another set of numbers. Satellite ground equipment, we have another set of numbers, and so on. So that's the table I want to create in R. And I want to actually put it into a different format. I want to put it in as a matrix with 5 rows and 5 columns, because that's going to actually be a very easy type of data which R can handle to create a very specific type of chart I want. So now I'm actually going to go back to my RStudio page. So that's my code. Okay, so we want to generate some side-by-side bar plots and stacked bar plots for this particular data. And for R, having this data in the form of a matrix makes it easier. So let's input this data in the form of a matrix. So the first thing I want to do is I want to type in all the space revenue values. And I'm going to put them all in one single object called rev.values. And this is a list of some 25 numbers, all separated by commas. Now notice the first 5 entries, right? All of these correspond to the first row we saw in the table. The next 5 entries are in the second row. Next 5 are in the third row, and so on. This will come in handy when I show you a particular argument in the function. So just make sure that you understand that the numbers are all going row-wise, okay? So I have a list which has 25 values. So let me run that and get it into my R environment. Now the next thing I want to do is I want to actually split this into a matrix. Convert this list of 25 values into a matrix which has 5 rows and 5 columns, just like how the original data looked. So the code to do that is to actually the function is just matrix. And I'm going to create a matrix with this name, space.rev. And I'm going to create a matrix where the elements come from this list called rev.values. And I want the matrix to have 5 rows and 5 columns. Okay. Now let me run this and I'll show you what the result looks like. So, but before that, maybe let's just see how the rev values list looks like. So it's just a list of 25 numbers. Now let's see how this command converts them all into a matrix. So space.rev Let me look at space.ref. There you go. So that's very neatly arranged in terms of matrix, right? We have 5 rows and 5 columns. It's pretty good. But notice all our entries which were in the first row in the data set are now in the first column. Second row data values are all in the second column, and so on. So we want to create a matrix, yes, but instead of numbers going by columns, we want them to go by rows. So I want this to become the first row, I want the second column to become the second row, and so on. So we can actually do that by adding one small argument to our matrix function, which is I want to create a matrix from these rev.values with 5 rows and 5 columns, and I want this to be done by the row. Now, let's see what R does when I give it that command. There we go. Now, all the numbers in the first row are in the first row in the matrix also. That works in the second, third, fourth, and fifth rows. So I only had to instruct R to create a matrix by going over the numbers in each row and splitting them up into rows and columns accordingly. So we've generated a matrix. Now the next step, okay, so remember that you have to keep periodically saving your R script so that you don't lose information. The next step is I want to give rows the different names and columns names so that it looks as close to the original data set as possible. So I'm going to create, there's this function called row names. Row names for space.rel is a list of all of these 5 different values. So the first row will be for commercial satellites, second will be satellite services, then ground equipment, and so on. So you'll have 5 different entries which correspond to the different names which we want to give the rows in space.rel, and the column names are given by the different years. So now let me run this row names command and the column names command, and now let me look at the space.rel data. Now every row has the name of the industry, and every column has a name which is the year in which for which we have information. Now this looks pretty close to the data that we initially saw, right? Which is this particular table. Our matrix mimics this quite well now. And now we're ready to be able to start generating some nice bar plots. So I want to draw a side-by-side bar plot or a grouped bar plot, where for each industry, I have the different revenue values in the different years are all shown side by side. So to do that, what I do is I just type bar plot. I want to draw a bar plot of space.rel, which is the matrix I'm interested in. And I'm going to write this command beside equals true. When I type beside equals true, it is indication to R that I want to draw bars side by side for the different columns in the matrix space.rel. So what this command is actually doing is for every row in space.rel, it considers every row as a particular category. And within that particular row, there are different columns, and each of those columns will all be the branches for that one single category. So that's how it's going to draw the graph. And I'm telling R that I want these to be drawn side by side. So let me actually run this and you'll see what I'm talking about. I made a mistake in that it goes by columns and not by rows. My apologies. So it draws a graph for every year. So for every column, it draws a bar plot where each of the bars are actually the different industries. So I mixed it up earlier when I spoke of it the other way around. But that could be an interesting activity for you to try out how to generate such a graph like that. So for 1990, I have these 5 different industries which are making different values, and I've already specified the Y label and the X label, and I've given it a nice title also. So this is a side-by-side bar plot, but it is missing something, which is it is not telling me what each of these colors corresponds to. So what I want to do is I want to add a legend. And how do I add a legend? There's just another argument that I add, saying legend equals true. So let me run that. And there we go. So we now have a legend. So the darker one is the commercial satellites and the lightest color corresponds to remote sensing data. But this legend is placed in a very awkward place where it is overlaid on top of a particular set of bars, which is not very informative. So the legend command itself has sub-arguments where you can specify where you want the legend box to be placed. So I do that in the next line here, where I indicate this as arguments for the legend command. And I write down a particular syntax which says I want the legend box to be in the top left corner because we have some white space there. So if I run that, it moves to the top left corner and I have neater looking graph. Now R picked these colors on its own. I didn't choose these colors, but I can go ahead and choose the colors. So I only add a color argument and I put the list of colors in a concatenated function. So maybe I want the first bar to be blue, then green and violet and gold and red. So you can look up R's color file, help file to see what name you have to give for each color. So check out the help file for colors and then you'll know what color is sky blue, what are the different colors available and the different names and so on. So suppose I want to give these colors. There we go. We now have a very colorful stacked or side by side or grouped dot plot for this particular data set. Now, the only other thing that I want to show you in this video is instead of grouping them side by side, I can also decide to stack one on top of the other. And it's pretty much almost the same code as we used for this side by side bar plot, except that now I'll tell R that I don't want them side by side. And that's all I need to tell R. It'll automatically put them one on top of the other. So the command for that is I'm just going to paste the same thing. So let me delete this code that I have here and let me type it out and show you. So I'm going to copy this command that I just used to draw this bar graph that you've seen right now. I'm typing it back. This argument where I say beside is true, I'm just going to go and change that to false. Okay, let me run this. And that's a stacked bar plot that you have where the values for every corresponding category are just stacked on top of the other and you have a very interesting looking bar plot. So I can change the colors here. Maybe I want this to be sky blue. Maybe the next one I want it to be dark green. Maybe the next can be yellow. Then this can be, say, pink. And then the last one can be orange. So let me try that. And it's given a different set of colors. And it's automatically updated the legend also, which is pretty cool. So that's what we learned so far. So we've done different types of charts. We know how to compute measures of central tendency, relative positions. We know how to compute variance and standard deviation. We know how to draw bar plots, Pareto charts, pie charts, histograms, scatter plots, side-by-side bar plots, and stacked bar plots. So that's quite a handful for you to learn. So I hope these videos have been helpful. And I will stop here and share all of these R scripts with you so that you're able to practice and learn from these files. I'll see you in another video.